Now, this is the new content which we are going to start in this particular week, that are the Newton laws, right? So, Newton laws. Anyone? What is the Newton's first law? Anyone who wants to answer, raise your hand. What is Newton's first law? What is Newton's first law of motion? Anyone? Give me a guess. Raise your hand and answer.
Sir, if an object is at rest, it will remain at rest, and if an object is in motion, it will remain in motion until unless an external force acts on it.
Okay, that's good. That's good. That is very good. ठीक है. हाँ. So let me just give you a historical background कि हो क्या रहा था. ठीक है. So we had this particular thing over here. Imagine this is your grass. ठीक है. And this was Isaac Newton's time, right? And he was sitting under a tree. I believe you all have heard this story. I don't know it's a myth or something else, but is what it is, a point after which these laws came into place, right? So basically, an apple, right, fell in front of him, right? So this was Isaac Newton, bhai, okay, and apple fell in front of him. So what would you guys do? Let's say you are sitting under the, let's say, bright day under the tree, and you're thinking about the life, right?
I would eat the apple.
Yeah, you would simply eat the apple. It's a red golden apple, right? It's a treat for you guys. You would just eat it out, right? So Newton bhai thought something. He had a thought process over here. Okay, why did the apple came down, right? So instead of a common human being as us, me and Ryan and every one of you, right, you would simply take the apple and enjoy your treat, right? But he thought, कि why? Okay, so physics का question, physicist, right? Every physicist, every physicist, ठीक है, जो भी theory discover हुई है, that was based on why, right? So every question, every theory started with why, and then they explored methods which explained why is it happening as the way it is, right? So after this, he discovered gravity. Okay, he discovered that there is gravity, and as soon as he discovered gravity, he placed his three laws, right? That we are going to study today, right? So the first law is as follows, right? So what is it saying? The first sentence, right? Let's go step by step. It will make sense. Let's imagine you're driving in a car, right? This is point A and this is point B, right? Let's say you're driving at speed u meter per second, and at point A, you basically made the speed to be zero. आपने accelerator पे आपने जो आपका foot था वो आपने remove कर दिया. You remove your foot across from the accelerator, right? So obviously at a certain point it would come to a halt. It would stop. So let's say it stopped over here, right? So the first sentence is saying कि on Earth, right, where you have friction and air resistance, if you basically leave your accelerator, the car would come to a rest after some time, right? Right? Or you switch off the engine. It makes sense, right? So यहाँ पे it came out to be 0 meter per second, right? Okay. So अगर imagine this, imagine कि if there was no friction, if there was no friction, so what would happen, Ryan? If there was no stopping force, what would happen?
Sir, uh, the object or car would go in constant motion.
Good. Imagine this is Earth over here. Okay, you are over here, right? And you throw a stone in space, right? In this direction. So it should ideally continue to move, right? Because there is vacuum in space, right? And vacuum means that there is no air. If there is no air, that means it has no air resistance, right? So he thought about this thing. Okay, in space there should be this phenomena over here. Okay, this object that is A, it should keep on moving till infinity, right? Similarly, this is the case over here. Imagine there was no friction in the car. There was no friction available on Earth, right? So the car would keep on moving in a straight line, okay, in a single motion ठीक है, with constant speed, right? So that is so. And then he basically went on. He said, that force is not needed to keep a body moving with uniform velocity, while there no force is basically opposing force are acting on it. Okay, so he's saying, that if you imagine this scenario, let's say he threw the stone at speed of 10 meters a second. So this was basically keep on moving in this direction for infinity, right? At a constant speed of 10 meter per second. If there is no friction, right? Yes, Ryan, you had a question?
No, sir.
Okay. So now imagine this. Say so this idea was proposed by Galileo and this was basically summed up in Newton's first law of motion, right? So what does it say? As Ruba said, कि sir definition Ruba ने बताई, that was exactly correct. कि what is Newton's first law of motion? An object either remains at rest or continues to move within a straight line at constant speed unless it is acted upon by a resulting force, right? So what does it say? What is Newton's first law? Newton's first law. Acha, it is also called law of inertia. Okay, law of inertia. So it says the following things. Okay, an object at rest remains at rest. Okay, imagine your car is stopped, so it will basically be at speed zero until unless you apply engine force to basically start it to move. Right, remains at rest. Okay, an object, an object in uniform motion continues to move at constant speed. Now, this is the interesting point. Until a resultant force acts on it to change its state. Okay. So this point is pretty important over here. This particular point is pretty important, right? So ये कह रहा है कि अगर object rest पर है, so object will remain at rest, right? That makes sense. An object at continuous motion will remain to move in continuous speed until and unless it basically a resultant force acts on it to change its state. Imagine कि यहाँ पे मून है, ठीक है, लेट्स से वो मून को हिट कर रहा है एंड देन ऑब्वियसली मून विल प्रोवाइड अपोजिंग फोर्स एंड ये ऑब्जेक्ट ए विल बेसिकली बिकेम स्टेशनरी एट हियर, राइट? सो उस पे रिजल्टेंट फोर्स एक्ट हुई तो वो रुका, वरना इट विल कीप ऑन मूविंग, राइट? दैट इज द समरी, दैट इज द क्रक्स ऑफ न्यूटन्स फर्स्ट लॉ, right? I hope it makes sense. If it makes sense, give me a thumbs up. This is pretty important, right? Does that make sense? It makes sense to Ruba, not Ruba, Rayan. Achha, it makes sense to Ruba, Rayan, Mashal, Azan, Maeve. What about Varda? Yeah, it makes sense to Varda. Yes, Varda, question?
No, sir, I don't have a question.
Okay, okay, good. दिस इज द फाउंडिंग प्रिंसिपल जो न्यूटन ने सोचा है, राइट? कि अगर मैं लेट से एप्पल को फेंक दूं, एप्पल को थ्रो कर दूं इन स्पेस, लेट से इफ आई थ्रो द एप्पल, लेट्स इमेजिन दिस इज एन एप्पल, राइट? इफ आई थ्रो दिस एप्पल इन स्पेस, what would happen to this apple, right? So he discovered these two principles, right? And it works perfectly fine, and that is why studying in your syllabus, right? अभी तक ये valid है, it has not been proven wrong till now, ठीक है? So okay, so how do we link mass and inertia? I said कि first law is also called law of inertia, right? So can anyone tell me how can I link mass and inertia? ये हम पहले पढ़ चुके हैं in the first chapter. How can I link mass and inertia? Anyone? It's a pretty interesting relation.
Mass resist change and inertia also.
Anyone, give me a guess. It doesn't need to be correct or wrong. I just want to see what are your concepts till now.
सर आवाज आ रही है मेरी?
Yes, Hamza.
अब मैं कह रहा था
हमजा थोड़ा जोर से बोलें.
mass resist change and also inertia.
Okay. ठीक है. ओके, सो हमने डिस्कवर किया था कि मास की डेफिनेशन हमने डिस्कवर की थी इन योर फर्स्ट चैप्टर कि मास इज अ मेजर ऑफ inertia of a body, right? So what is inertia? Inertia means के resist, ठीक है? It basically means laziness, right? Let's imagine you're waking up on Sunday morning, right? This is your bed, and let's imagine if I draw Hamza over here. This is Hamza, right? Hamza is sleeping over here, right? If I wake Hamza, if let's say if Hamza's mommy wake him up on Sunday morning, he would say, "No, I just want to stay asleep, right?" So इसकी जो हमारे पास current state है that was basically sleeping and he wants to continue to sleep, right? That is inertia, right? Imagine if a body is at rest, okay, it wants to stay in rest. It doesn't want to move. If a body is basically moving, right, in this direction, and you want to stop it, it would basically make sure to keep on moving in this direction. ठीक है, हमने example लिखा था. We saw the example of a bus, right? We saw the example of a bus, and let's imagine this is Azan over here. Azan is standing in the bus. Let's say, ये समझो. Let's say the bus driver saw the bump over here, saw the basically a ramp over here. He applied the brakes, right? So Hamza ki body, basically the bus was moving at a speed of 20 meter per second. So since Hamza is standing inside Anas is standing inside the bus, so he would basically also be moving at a speed of 20 meter per second. Bus ने brakes लगा दिए, the speed became zero. At this point, the speed became zero. But Anas' body would basically want to move at constant speed at 20 meter per second. That is why you have a jerk, right? You basically undergo a jerk when the brakes are applied. The body wants to keep on moving, right? It wants to maintain that state. It doesn't want to change its state. Okay. Similarly, so since mass, the body is composed of mass, so inertia आता है basically from property of mass, right? So we can define mass as a measure of inertia, right? Okay. So this point is explaining this case. If let's say a body is moving in a straight line, imagine this scenario. And if you apply the brakes, the body would want to move at constant speed. It doesn't want to stop, right? So you basically have a jerk on your body. Then you basically control using, let's say, a pole inside the bus, or you use your feet to basically stop yourself, right? Okay. So the greater the mass, the greater the inertia, right? So जितना बड़ा inertia होगा, it is more difficult to move. For this, let me give you an example. Okay, what happened over here? Imagine you have an elephant, right? You don't have an elephant. Imagine you have an elephant in the zoo, right? We have an elephant in the zoo, right? Elephant की मैंने बना ली है, right? Elephant come over here and it has its ears, it has its leg and it has teeth, right? Right? Let's say if you want to, this is let's say if you want to move this elephant, right? Imagine Hamza goes to a zoo. Hamza wants to test this phenomena. Hamza wants to apply a force on this elephant, right? Now, as compared to this, we have another scenario over here. Let's say this is Anas over here, and let's say we have Ruba over here, right? Ruba wants to, let's say, push Anas, right? So, which object is easier to move, elephant or Anas? Imagining Anas is a smart person and he weighs around, let's say 55 kg, and the elephant weighs around 5500 kg. So, which thing is easier to move? Which object is easier to move, elephant or Anas?
Unless
Anas, right? So you can just compare this, right? दोनों रेस्ट पर हैं अभी, दोनों रेस्ट पर हैं, right? They are standing over here. They are standing over here, right? So you can compare this. So inertia क्या होता है? It basically resists change, right? So inertia is a property which resists change, right? So since elephant and Anas were standing at stationary values, so they would want to stay at rest, right? But again, if you apply a force, this force is enough to keep basically push off Anas, but it is not enough to push off an elephant, right? So यहाँ पे इसका inertia is huge. So the inertia of elephant, this is inertia of elephant and this is inertia of Anas. So inertia of elephant is way greater than inertia of Anas, right? This is the idea of inertia and mass relation, right? Okay. So I hope it makes sense. And just this is an experiment which you can do at your homes. Just take a cardboard, ठीक है, let's say a wooden cardboard, and place a coin over here, right? And you can just place this experiment as it is shown over here. If you quickly basically apply a force in this direction, what would happen? The coin would remain stationary, ठीक है, but this card would basically come over here, right? ठीक है, keeping in mind कि आपने motion बहुत तेज किया है, keeping in mind कि your speed is pretty great, right? So this coin, which was at rest initially, would basically again try to maintain at rest state, right? So this basically shows the inertia of a body tries to resist change. If it is at rest, so the coin would again want to stay at rest. It basically won't have to change basically state. Okay. So this is one of the experiments which can show you relation of inertia and mass. Okay. Does that make sense? If it makes sense, give me a thumbs up. This idea is pretty important, right? ये आपके आगे कब चलेगा in your next future chapters. So make sure that it is pretty clear over here. Okay. It makes sense to everyone.